All right, we are officially live, and let me make sure it's recording. Yes, okay. Perfect. Welcome, everyone. Okay, I see folks joining now. Perfect. All right, I'm going to start my introductions because most people have already heard them, and I'm not the main speaker anyways, so I want to get it over to all of our fabulous speakers. So, welcome everyone who is joining. We are going to get started with our Hemlock Woolly Adelgid Lunch and Learn. Thank you all for taking time out of your day and hopefully eating some delicious food during your lunch break and listening to us all talk about Hemlock Woolly Adelgid. My name is Camille Marcotte, and I'm the Water and Ecology Educator with Cornell Cooperative Extension in Onondaga County, and I work as part of the Skaneateles Lake Education Program, which is funded by the City of Syracuse to provide education to help protect the water quality of Skaneateles Lake. I'm going to go over just some quick logistical items, and then I'll turn it over to all of our presenters for today. So this online program will eventually be followed by an in-person event on July 19th, so stay tuned for more details on that. We are currently using Zoom in webinar mode, so you are all muted right now. There are a lot of you who have signed up, so I just want to make sure that there's no background noise happening. But if at the end you'd like to ask a question using the mic and audio, you can raise your hand, click the raise hand button at the bottom of the screen, and I can unmute you. We have 3 presenters today, and we're going to be waiting until the end to answer any questions. But feel free to type any questions throughout the webinar into the chat and or the Q&A sections. If you use the Q&A box, you can ask questions anonymously if that's more comfortable for you. I'm going to monitor both of those for when we get to the end for the question and answer portion. This program is being recorded and it will be available to watch on our CCE Onondaga YouTube channel. The link to the video will be shared in a follow-up email along with an evaluation and any resources, and I'll also post the link to the program evaluation in the chat as well. Please take a few minutes to fill that out after the program. If you run into any technical issues throughout, please either email me, I'll put my email in the chat, or message me, and I'll do my best to respond and help you troubleshoot. I might not be able to help you, but I'll do my best. But that's all from me. I'm now going to turn it over to our first speaker, Carolyn Marshner, who is the Invasive Species Extension Associate with the New York State Hemlock Initiative. So take it away, Carrie. Thank you so much.
Thank you very much. I'm with Cornell University, College of Agriculture and Life Sciences, and New York State Hemlock Initiative. And I'm super grateful to be here today talking with all of you. Hemlocks are a common tree species in New York. They used to be the 3rd most common. They're currently the 4th most common, I think. And they are what we call a foundation species, which means that they create the ecosystem that other species depend on to survive, because they are what makes a hemlock forest, right? They provide a whole bunch of different ecosystem services to terrestrial ecosystems, aquatic ecosystems, and from the perspective of the Skaneateles Lake Association, they help keep stream temperatures even and cool by the magic of being hemlocks. And because we're trying to get on to other portions of the talk, I'm not going to delve too far into that, but you can reach out if you have any questions. And they are being threatened by Hemlock Adelgid, which is an invasive forest pest that we probably all know about. It looks like this, the white woolly masses that are on these twigs here at the base of these needles. There are a bunch of places where hemlocks live all over the world, and there are native hemlock adelgids throughout the Asian range of hemlocks. There are quasi-native adelgids that arrived over 50,000 years ago on the west coast of North America, where they now function as a native species because the trees have gotten used to them and there are insects that are predators on them. It's just us over here on the East Coast, probably with our glaciation history, that don't have any adelgid pest for our trees, which means our trees aren't adapted to this kind of pest, and we don't have anything that eats them really. And that's why they're a problem here. So this is where HWA is in New York generally. It started down towards the city in the 1980s, slowly moved through the lower Hudson. It also had some spot infestations pop up in Buffalo and Rochester from infested trees that came up in the ornamental trade. And then it spread through Finger Lakes, and it's moving into the Adirondacks and filling in all of its holes in Western. And we've added a few more townships since last year. Here it is with the white waxy woolly masses on the base, on the twigs at the base of the needles, often on newer foliage, but not always. So this insect reproduces asexually, which means one bug can start a new infestation, 2 generations a year, 2 opportunities for exponential growth, and as we just discussed, no native predators of HWA. And that is why we have such an issue with high hemlock mortality on the East Coast. Takes between 4 and 20 trees usually to kill a tree on the East Coast of the United States. Eastern hemlock and Carolina hemlock, which is another hemlock that's restricted to a very small portion of the United States Southeast. In the South, it's more like 4 to 10 years. Up here in the North, it's historically been more like 6 to 20 years, but with the very warm winters we've seen the last couple of years, we've seen accelerated damage that looks more like the South. So I work with the New York State Hemlock Initiative. We are part of Cornell, part of the College of Agriculture and Life Sciences, and we eat, sleep, and breathe finding a biological control solution for hemlock woolly adelgid. We're also starting to work more on integrated pest management more generally for hemlock woolly adelgid and long-head hemlock scale in order to conserve our very common eastern hemlocks here in New York. There are a couple of different ways you can think about management for HWA. There's short-term management, which is pretty much exclusively chemical control of hemlock woolly adelgid. And then there's the long-term control options, which are biological control, our bread and butter, and potentially finding a way to breed a HWA-resistant strain of eastern hemlock, which is not our bread and butter, but we're starting to engage in that space. And if you are going to save the trees that are alive today, you need to treat them. And generally there are 2 chemicals that are used for that. Imidacloprid, which takes about a year to become effective, but then it lasts for 3 to 7 years with an average of 5 years. It used to be widely available, but as of June, it will be only allowed to be applied by pesticide applicators, professional applicators. Or dinotefuran, a related chemical, but it works right away within a few weeks, and it's gone in a year. So you would pretty much never use just dinotefuran because that would be silly. It's 5 times as expensive as imidacloprid, and it only lasts for a year. But there are situations where you want to add that to an imidacloprid treatment to save an old growth tree or a tree that's declining very rapidly and has a very heavy infestation. Those are the situations. Or it has a longet hemlock scale as well as hemlock woolly adelgid. Those are the 4 situations where I would say a tank mix would make the most sense, even though it's more expensive. This can only be applied by applicators. You can do a basal bark application, which is most of what we do in New York. You can do a stem injection where you drill it straight into the tree, which has very few off-target impacts and is often used near water. Or there are several kinds of soil applications that are used more in the South, but are also very effective. And I'm now going to hand it over to the next presenter.
Great. Thanks so much, Carrie. Carrie will be back, so don't worry if you're like, that was short. She will be back, but I'm going to turn it over now to Frank Moses, who is the executive director with the Skaneateles Lake Association, to kind of talk more about what's happening locally here in the Skaneateles Lake watershed. So you're all set, Frank. I'm going to spotlight you and you're ready to go.
Great. Thank you so much, Camille. Carrie, that was a great introduction. Appreciate all the support from Cornell, especially dealing with this critter that's literally sucking the life out of these trees. Just going to give just a bit of a background of the Skaneateles Lake Association and our involvement in this and the program, and really just do a 5-year look back of really only because that's about 5 years ago I came onto the scene and got introduced to this. So I'll talk about what I know. But basically, we're working in every way we can to care for Skaneateles Lake and its watershed. This photo to the right is on the left is the late and great Dr. Robert Werner, limnologist from ESF, and our co-chair of our Skaneateles Lake Association, the Lake Ecology team, Dr. Bill Dean. But Dr. Werner was absolutely a pioneer to protection here, and back in the 1970s, and as Carrie mentioned, the upswing of the hemlock woolly adelgid in the 80s, where Bob was mentioning if we lose our hemlocks, we lose the lake, and that's been very much a battle cry related to our programming. Just to talk a little chronologically, 5 years ago, the relationship with Cornell has been wonderful. I first met Camille in March 2020. There was a workshop. She brought Steve Kinney in from the Central New York Hemlock woolly adelgid hunters, and we went out into the field at High Hickory with the Central New York Land Trust property and down to Lourdes Camp. And at the parking lot, there was a wonderful SLA member, Roseanne Gay, and I said, "Hey, are you going on the field trip?" And Roseanne said, "No, I'm here to see if anybody from the Skaneateles Lake Association cares about these hemlocks and these issues." And boy, was I glad I was there, and the rest is history. We reached out and connected with the Soil Water Conservation District when we looked at some grants, and wanted to really thank Dr. Dana Hall, who's our board president, who we met with Mark Berger from Soil and Water, and said, "Hey, we kind of came together and had the same idea. Let's try and do something." And there was a grant. And we reached out to it because they were in Onondaga County, connected with a Tisco Lake, and not similar to our watersheds where the raindrops hit and water comes down to Skaneateles Lake. We actually share forests and these land properties where the hemlock woolly adelgid don't care if they're in the Owasco, Atisco, or Skaneateles watershed, or throughout the Finger Lakes or New York State. But we saw it as important to work with our neighboring lakes as a strategy and to see that all boats rise with the tides in that. So part of that was we did some cost sharing on supporting the development of the application to the USDA, and then found out it was awarded $50,000. And that work with the Soil and Water has been looking at these accessible areas that are in the uplands and not in the steep ravines as much, or by inaccessible shorelines, and which I'll get into that and the relationship there, but really protecting where they could do some in-house protection, and really saved a lot of dollars because of that in-house treatment that folks like Teresa Link at Soil and Water could get to the areas. But that kind of made us look at the steep ravines, the shorelines, to do kind of a gap analysis to say, what do we need to do with these private lands to get into these steep areas? We know the DEC, the Land Trust, both Central New York and Finger Lakes Land Trust, are taking this on themselves, and also working on ensuring that there's support there. But how could we work with private landowners to move the needle and protect our needles of these trees in, again, those steep ravines and along the shorelines? So that's just a little 5-year history. This is Steve Kinney from that presentation 5 years ago. And we introduced Steve to Dana Hall, who then brought Steve to the Owasco Lake, and then Dana, through that Owasco Lake relationship, also connected with Zeb Strickland, which I'll introduce later. And we started working with Zeb on the Skaneateles Lake part. So First thing was we had to look at where are our hemlocks in the lake. And so we hired an intern from the SUNY College of Environmental Science and Forestry, Will McCall. And Will helped kind of do these shape files of where coniferous forests are. And then we tried to figure out and still look at this map on where our hemlock forests are and looking at these steep ravines, but also looking at the shorelines. This is an example on the left of these ghost trees on the banks of Skaneateles. And then on the right, this is kind of the worst case scenario. This is not hemlock banks per se, but this was a property that someone wanted to have a unimpeded view of the lake. And so they took down the trees on top of a steep bank and the steep bank failed. So that's one of the reasons why we're prioritizing the zones of these steep banks to maintain any tree, but specifically hemlocks to the south of the lake. Our first area that we looked at where Onondaga County Soil and Water did the upland parts and did some treatment. And then we looked at could we fill in the gap of the steep ravines, namely to protect the steep banks from this erosion. And this is just an example of when we sampled after a storm what 10 Mile Creek can do. And so there's not really an engineering solution in the steep ravines. This is an example of when you get to the flats and towards the mouth of the stream where you can do some stabilization, but we have to look at what are our strategies in the steep areas to protect our soils. And really it's protecting the roots of these trees. This is just looking at getting into the maps. And again, here's those shape files of coniferous trees around Skaneateles Lake. Some are Christmas tree farms and white pines, but there's a lot of them. Looking at this is an April 2017 Google Earth image, which gives us what the land looks like before the deciduous or your oaks, maples start to leaf out. So we can just see these coniferous forests that run along the stream banks to the south of the lake. And then these white areas are the areas of where we've done the treatment, and then looking at what we've done since from 2021 to 2025. I also wanted to recognize Dr. Buzz Roberts. Buzz is actually hailing, I think, online right now from overseas, traveling. And Buzz has really taken on the torch from Dana Hall to work with Zeb Strickland in working with our private landowners to engage the landowners, educate why this is important, and to look at multiple properties across, that where people have shared forests to try and coordinate in scheduling Zeb and treatment professionals to not just go to one property, but try and go to multiple properties in one forested area. So to date, we've protected over 2,800 trees in these residential priority zones. And out of the residential priority zones, it's about over 80% of our goals before we look into other phases, but want to get these steep banks and these steep ravines taken care of. And we're gonna, stay after it. So that's just a brief synopsis of what we've done, how we got here, where we're at from the Skaneateles Lake Association side of things, but it does take everybody, like I mentioned, the soil water conservation districts, the DEC, Cornell, our private landowners that have decided to, hire vendors and treatment professionals to do this on their own. So we want just to thank everybody and thank everyone that's really gotten behind the Legacy Fund through the years that's allowed us to direct these private dollars and also leverage for, future public dollars too. And so that's about it, but I'm going to stop sharing now because I did want to introduce Zeb Strickland. And Zeb's the owner of the Forest and Water Solutions. He's dedicated decades of his career and education to the environment. He has his master's in natural resources from Virginia Tech. Is a certified tree risk assessment and certified as an arborist from the International Society of Arboriculture. He's worked in sustaining our forests and waters with Cornell, U.S. Fish and Wildlife Service, the USDA's Forestry Division, and others. Zeb, so glad you're here, and thank you for your time. You've been a critical expert in supporting Skaneateles and other Finger Lakes. And thanks for taking the time out of your day to connect with our community and share your knowledge.
Great. Thanks, Frank and SLA, for having me speak today. And yeah, I just want to thank you all as well for supporting me as we kind of, figure out this big landscape scale situation with hemlocks throughout the Finger Lakes. So anyways, yeah, so I own Forest and Water Solutions. I do treatments kind of throughout the Finger Lakes, focused on invasive species, and I've done a lot of work up in Skaneateles Lake and Owasco Lake and surrounding areas, just to save these magnificent species. Sorry, and so yeah, if you want to hit the next slide, Frank, I'll just kind of do a quick overview. So I'm going to kind of talk about the treatment methods, what it takes to go into to treat these trees, and then kind of the considerations and factors that go into this, and then a little bit more detail of the longevity of these treatments. So as far as going in, we're using basal bark applications and injection methods. Carrie had mentioned there's many different types of treatment methods you can use. You can use soil injections, drenches, different types of methods. These are more focused on, we really want to have the least environmental impact. So that's kind of why we're using these type of methods. Basal bark application, you're looking at treating the trunk of the tree. Generally inexpensive, depending on what types of insecticides you're using. And the benefit to these insecticides is they're really highly water soluble, so they'll really get up into the tree, kind of the whole system of the tree impact. But we also need to be careful with, because they're highly water soluble, there could be runoff into the creek. So just taking precaution to different types of methods is what we need to do. And then so there's basal bark, and then injection is more, if we're in an environment that's closer to the water, we're going to want to use more a stem injection, because basal bark application can have potential drift into the water. So if we can do a combination of these to have less environmental impact, that we're on the right path. The other thing I want to mention too is, when selecting these trees, we're going into these steep slopes, so we need to, as an applicator, I need to take precaution as we're doing the treatments on these cliffs. So sometimes I do have to use ropes going into for basal bark application and injection, just for, I don't want to be falling off cliffs, because some of these, a lot of the hemlock habitat is in gorges. So we got to have consideration there as well. So I wanted to just to give you an idea of this is going to be an injection method here of kind of why we're choosing injections, and just looking at if you're looking at the cliff there, you can see the roots are entwined in that bank and stabilizing that bank. You can see the tree is kind of over the water, so we're going to use the stem injection method, because we don't, as a basal bark application, if you're spraying on that trunk, there's potential drift into the water, so we need to be careful what we're doing. But this is kind of what we're doing. And this tree is also along the shoreline, so it's providing shade to lake as well. So you can see I'm kind of tied in there. Awesome. Next slide. Thanks, Frank. So there's a lot of kind of considerations we need to take when looking at these. Soil temperature and moisture. There's in the springtime when the soil hits 40 and above is a good time to start treating. You don't want to go below that. I mean, it can be plus or minus, but you don't want to go below that because the trees need to uptake the product. So you're going to get a more efficient application if you're starting in like mid-April, and then you can treat throughout till June. You also have to consider moisture aspects as well. You don't want to be treating when it's drought, because the trees are going to close their stomates and they're not going to want to take much of the product up. So there's also, when looking at trees, we're looking at the tree too. Is it a healthy tree? How impactful has the Adelgid been to the tree? There's a certain threshold where you might not want to treat the tree. Generally, it's below 30% canopy loss, but that depends on also site factors. Is there organic matter? Is there enough organic matter for that tree? Is there growth prior to is there growth prior to the prior year that, okay, maybe we can treat these trees. We got to consider active ingredient per acre. With imidacloprid, there's a certain limit you can treat, a certain amount of product you can put out per acre. So when going through these stands, you kind of have to judge whether you're doing multiple seasons of treatments. You can go through and do some treatments on a stand, and then you might have to come back and treat the following year. Weather conditions. So weather conditions are like, okay, if it's going to have an extreme rain event, you don't want to be applying right before that, particularly with dinotefuran, because being that it's very highly water soluble, you don't want that chemical to run off into the water source. We kind of talked about the proximity to water line a little bit. You saw the video on the prior slide, but yeah, just determining you don't want to be doing basal bark or even soil applications too close to the water. So you want to take considerations in that. I know there's been a lot of research saying there's really not much. The product does bind at least close to the tree, so you really don't get too much impact. But you need to be just taking precaution of where you're treating near water and whatnot. So, is there anything else I wanted to talk about that? I don't think, let's move on to the longevity. So as far as like using these products for basal bark applications and stem injections, so dinotefuran is highly water soluble, more than imidacloprid. So the benefit is it gets into the tree within a couple weeks to have impact on the Adelgid. The problem is in 6 months it kind of hits a peak, and the efficacy of that product is reduced. So generally you're getting about 1 year. You're getting about 1 year treatment efficacy with dinotefuran. With imidacloprid, on the other hand, it is still water soluble, not as much as dinotefuran. But what happens is, it's slower to move throughout the tree. So it might take a year for it to actually fully inoculate the tree, kind of the whole tree system. And however, it binds to this kind of woody material in the tree more so often. So that's why you get this longer, you get this 5 year, I think Gary was saying between 3 and 7, average 5 years with imidacloprid. And so when looking at these sites, you're kind of determining, if you have an unhealthy tree and it's in that threshold, you want to consider maybe between 30% and 50%. You might want to consider both chemicals, because wow, it's highly infested, and the dinoterfuran is going to get in there super fast to kind of take that generation out, and then the imidacloprid is going to be that long lasting. So you might get actually 5 to 7 years with dinoterfuran and imidacloprid. So yeah, it's just understanding, you know, the benefit to these insecticides is that you know, you're getting more bang for your buck. So you know, it's inexpensive. You're getting long. You don't have to go back and do multiple applications, and so yeah, that's kind of looking at that basal backup a little more closely. So and so on that, I want to, you know, as a whole, we need to kind of understand the landscape as we're going into treating these populations. We have to take care into treating these systems when we're going into these systems. You know, generally, if you're looking at IPM or integrated pest management, you always kind of want to do the cultural, the biocontrol methods are kind of the first approach. Pesticides are always the bottom of the list, but when you have an impact like this as a whole, the ecosystem services that hemlocks provide, sometimes you do need to use that tool as an approach to combating these invasive species. And you know, one thing on that, you know, fortunately, there's been a lot of research and, you know, innovation and technological advancement with insecticides, so we can kind of focus more, you know, less environmental impact, you know, more focused approach with these insecticides. And then, you know, it is a more, obviously it's a more short-term kind of solution. So we want to look at more of the long-term solutions. And now I'll direct it back to Carrie from Cornell she's kind of expert in that, but thank you.
Great. Thanks so much, Zeb and Frank, for kind of talking about what's happening locally here in the Skaneateles Lake watershed. And I'm going to turn it back over to Carrie Marshner to kind of talk about the future and the biocontrol and kind of where management might be moving in the future.
Thank you very much. I'm going to stall a little bit while my computer pulls itself together so I can share again. I wanted to talk a little bit, given some of the comments in the chat and some of what Zeb has been saying about some of those. Just give me a minute. I'm gonna get through to where I'm supposed to. So I wanted to talk a little bit about some of those ecosystem services, particularly from a water perspective. Hemlocks are one of our only shade adapted hemlocks. So they're living in places where other evergreens don't grow. And the way that they're providing these aquatic ecosystem services is that you have this evergreen tree that's in these shady places right along your rivers. It's providing filtration. It's providing deep shade in the shoulder season so that it's directly cooling water. And it's also, because it's pulling up water in the spring and fall when our broadleaf trees are not, and when we have an overabundance of water, it's helping reduce some of those high flows in our streams in the spring and fall. And because it's not pulling as much water in the summer as those broadleaf trees, it's reducing some of the drawdown in the summer when we don't have it.
Carrie, your audio is a little weird. Are other people hearing that? It's a little kind of cutting in and out a little bit, or it almost sounds like robotic, but maybe that's just on my end. I don't know if anyone else is hearing that.
It's a little choppy. I'm not sure if it's the mic or not.
Let me try.
Yeah, I see other folks are saying yes, they're having the same issue.
Okay, well, I'm gonna just
whatever you did, that sounds better.
Yeah, it sounds good now.
Okay. Maybe I'll get rid of that particular set of headphones. All right, now I think I'm ready to actually, but it's okay because I didn't have a slide for this. And those ecosystem services are really hard to reproduce with any other tree. So when you lose a super abundant tree that has a very unique set of services that it provides to us and to the ecosystems around it, it's really important to try to keep that species in the landscape. And that's why we're so laser focused on hemlock management. The other thing is that when you're thinking about the risks and the cost benefit for whether to treat or not to treat, remember that it's not, I'm going to treat and there may be some off-target impacts versus business as usual. It's, I'm going to treat, there may be some off-target impacts versus I'm going to have a different ecosystem here. And the species that were here are not going to have the same ecosystem anymore. And so you're going to have a reshuffling of your whole system, both plants and animals. And that's often a larger impact than the impacts of treatment. There's a woman from the southern portion of Hemlock's Range. Her name is Elizabeth McCarty. She's been studying the off-target impacts of the treatments we've been discussing since 2015. And she's done some really excellent work, and I will try to, she has a great summary of the impacts that she has seen and why she thinks that hemlocks are a good place to use these chemicals. And I'll get that to Camille so she can share it with the audience. So back to our regularly programmed talk. Hopefully you're seeing something that says long-term management. Is that what you're seeing?
Yes, looks great.
Thank you. So the two things that I'm going to talk about are biological control and resistance breeding. Biological control, again, are meat and potatoes. So biological control is great because it's a long-term solution that functions at the landscape scale. The downside is that it's not ready for prime time yet. The biological control programs take a really long time to test and implement, in part because we are very careful about anything we might bring into an ecosystem to try to control an invasive pest for obvious reasons. So there's a lot of testing that needs to happen to make sure that whatever it is that you're going to bring into a new ecosystem is going to be laser focused on the thing you're trying to control. And the other reason is it just takes a lot of time to figure out whether that insect will do well here and for its populations to increase. So we have two different kinds of insect that we work with. There's silverflies and Laricobius beetles. We generally work with two species of each of those. So let's talk about Laricobius beetles. These guys are from the Pacific Northwest, from that area, remember, where HWA arrived over 50,000 years ago, and now there's a whole, they're just integrated into the ecosystem. We've been working with this pest since 2009. And we actually now have more than 30 places where we have found established populations of Laricobius beetles on our landscape. This is what they look like when they're doing their thing. You can see that the white woolly masses that are the way you find HWA have been all pulled apart, and they're just eating those bugs, which is great. That's what they do. These are the places where we have released these insects as of this winter, I believe. You can see the release size with the black circles. The yellow stars are where they've established, and we're most excited about the red crosses because those are the places where we didn't release them and they have spread to and are now thriving and eating HWA in those locations as well. And that's always a great, that's sort of the goal of a biological control program. The issue with the Laricobius beetles is that they only eat one generation of HWA. And so that manages one of the opportunities for exponential growth in a year. But you need something to deal with the other generation as well. Otherwise, they just bounce back every year. to the silverflies. The silverflies are also from the Pacific Northwest, but they feed on the other generation of HWA. They eat their larvae eat the eggs of HWA. Yeah, and we've been working with them since 2017, more rigorously since like 2020. And we've done a lot of research on these. Many other states are also working with them and trying to get them to establish. We have not found establishment in New York yet. These guys are very small and hard to find. There are 2 flies one's been found in Virginia. That's several generations removed from the release. And there's one found quite close to New York, just south of us, that was 1 generation from release. But we haven't found an established population here in New York yet. Fingers crossed, we do believe they will establish. Stay tuned. This is what they look like. These are not large flies. They're very, very small. And those are the larvae eating the eggs of HWA. So this guy, a little less charismatic life stage of this fly, is what actually eats the eggs. Here are the eggs, and that is the rear end of an HWA. This is where we've released in New York. So we've been hard at it. We're hoping they establish and that they will help control that other generation of HWA. Probably the medium-term solution is integrated pest management, just like Zeb said, where you are treating the trees that are alive now. Nobody can afford to treat them all. So there's always untreated trees with food on them for the biological controls, which you can release at the same time. Usually we ask for about 1 year to 1.5 years of lag between a treatment and a release. And there's an actual established protocol for that. So this is something that we're all excited about, saving the trees we've got now and trying to save our long-term forests as well. That other long-term solution, potential solution, is finding a resistant or breeding resistant hemlocks. So hemlocks that are able to be infested by HWA but not die from it. And we are participating in a much larger project that's being managed by the Nature Conservancy. It's called Tree Species in Peril Project. And this is a project to look at developing genetic resistance for vulnerable, mostly northeastern US tree species. There's 5 of them. There's the 3 species of ash, and they're getting really good results for green ash and white ash. The black ash is harder. I'm not sure why, but the first 2 are doing really well. Then also the American beech. There was good progress for American beech and beech bark disease, and now we have beech leaf disease. And so those researchers are scrambling to try to figure out how to find resistance to major pests at the same time. And then there's eastern hemlock, and we are very much at the early stages of this process for eastern hemlock. So the first thing that you do when you're trying to find breed resistant strain is to find trees that are lingering, which means most of the hemlocks in an area have died, but these guys are either very healthy or just healthier than the ones that have already died. The really healthy ones, might have a great resistance gene, but those ones that are just a little bit healthier can have a tolerance to a pest that will help them hang on a little bit longer. And you really want to capture those tolerances, because in a breeding program, you can layer different kinds of tolerance over each other to develop a much more robustly resistant tree. If you don't have 80% mortality, which I'm hoping you guys don't have that Finger Lakes in the Skaneateles watershed yet, they do have it in some places in the Lower Hudson where they're just looking for lingering hemlocks now. But mostly in the Finger Lakes, we haven't hit that 80% mortality threshold. If you haven't hit that, then what we do is we set up hemlock health monitoring plots, where you take some trees that you're not going to treat, and you watch them over the years to see when do we reach that 80% mortality where we can start searching the landscape for lingering hemlock, because that's how we can develop a at HWA resistant hemlock. And it's really important, but it's sort of a long-term goal. So we are collaborating with the Nature Conservancy to provide outreach materials for this, and we can come and train your group or your volunteers if they want to set up some lingering hemlock plots in the Skaneateles watershed. Let me know. I also want to just very briefly touch on a new program that we just got funded that's focused on what you do after you have a lot of HWA mortality in a changing climate. So you're here. We're not here. We're still working very hard to save our trees, but in the Southern Appalachians, they're here, where a whole lot of their hemlocks are dead, and they need to figure out how to manage a forest that looks like this. What do you do? When you think about changing climate and how things are going to be more and less happy in places where they have been for a long time, there's this new framework that you can use to think about this called climate adaptive silviculture. This is not my work. This is work from the Northern Institute of Applied Climate Science. I'm going to present a few of their slides because they're super relevant here. So one option is, I have a stand of hemlocks. They are in the perfect place for hemlocks. I think they're going to survive here for a really long time. I'm going to keep this place a hemlock stand. That is resistance to changing climate. And there are certainly places where this is completely appropriate. We're right in the middle of hemlock's range. There are a lot of places where hemlocks are going to be, even if we utterly fail to manage our climate situation. And so in New York, there are probably a lot of places where you should just be trying to conserve your hemlocks and replant more hemlocks, particularly if we can breed resistant hemlocks. But there may also be places where you think hemlocks do pretty well here, but it's kind of dry in the summer. And I'm not sure they're going to do great in the long term. So maybe I'll introduce some other species that provide some of those same ecosystem services that the hemlocks do, just to bolster my my forest and make sure that it does well long term, even if the hemlocks here do not continue to thrive. That would be resilience. So you're keeping the ecosystem, but you're changing it a little bit. And then there might be a few places, maybe in the lower Hudson, where it's very hot, it's very dry already, and the hemlocks are there, but they're not doing so great, and they're probably not going to stay there in the long term. And that would be a situation where you might say, what can I plant here that will do well with climate change and provide at least a subset of the ecosystem services that those hemlocks did by cobbling together some species that would do okay in this area, provide some of those ecosystem services, and will do well long term. That would be a transition approach. So we've got resistance, resilience, transition. And part of thinking about forest management in a changing climate is looking at your forest and saying, which of these buckets does my forest fall into, and how does this fit in with my goals for my property, to figure out what I'm going to do with my forest moving forward. Right now, we have no advice for you, but we did just get a grant to work with Tony Devata, who's has done a lot of work in this climate adaptive forestry space in northern forests, to try to develop some strategies that people can use that will be appropriate for the ecosystems where hemlocks live on the East Coast. So we just got notification of funding like last week, and I'm really excited to hopefully get this project up and running in 2 or 3 years. We should have some solid recommendations for you. And so stay tuned. And that is all I have for today. And I think we've got some time for questions.
Yes.
Here's where you can find us.
Yes. Great. Thanks so much, Carrie.
Thanks so much, Karen.
And everyone, this was really fantastic. I learned so much personally from everyone. So we definitely have time for questions. So let me start going through and see. I don't think anyone put anything in the Q&A. So let me go through the chat. The first question we received was, what does it cost to treat one mid-size hemlock tree with imidacloprid? So maybe someone can talk about kind of the costs of treating trees.
I think this is all Zeb.
Yeah, Zeb.
Yep.
Thank you. Yeah, so generally there's an average cost. So if you're going to treat a tree just with imidacloprid, I think the question was an average, maybe mid-size 15-inch DBH tree. You're probably looking at about $15 for that tree. So maybe you'd average $1 an inch, and that can fluctuate with the economy and you know, we've had a lot of inflation issues, so there's a lot of costs that can go into it. So it can drive it up a bit. So generally it's inexpensive when you're adding the dinoteffuran. That's why you kind of have to make these decisions. That can drive the cost up quite a bit, just because the insecticide is a lot more expensive. So, but on average, that's what you're looking for. A tree that's healthy. If it's, for example, if it's unhealthy, then you're probably looking at maybe $3 an inch, just as an example. And a lot of factors go into that, like site access. You know, if we are using fall protection, it's more time, more labor to get down into there, more technical expertise. So expenses can change there as well. So.
Yeah. And if you are, I'll just add, if you are in any of these steep ravines on Skaneateles Lake, or have a swath of hemlocks that run along the shoreline banks, please, feel free to reach out to the Lake Association, and we like to see how we can coordinate across multiple properties if possible, and try and get after these priority zones, just to buy us some time until things get rolling with the advances in technology and biocontrols.
Great. Thank you both for that answer. Another question that came in was, will hemlocks on the East Coast eventually develop adaptations to the Adelgid with the help of biological controls, or will that take thousands of years?
So without any biological control research over thousands of years, they would develop some kind of resistance. And there's actually an interesting story from paleohistory about this, which is that in geologic time, a while back, hemlocks abruptly disappear from the pollen record. So you can go to a lake and like sample the lake sediment and then look at the pollen grains and see what was growing near that lake over thousands of years. So that's the pollen record. And hemlocks disappear almost completely from the pollen record for a few thousand years. A while back, maybe 150,000 years ago. I don't have the exact age in my brain. And it's not related to glaciation. We think it's related to a new pest arriving, potentially also with a climate change factor. There's a little disagreement in the literature about whether it's climate or the hemlock looper, but they think it was the arrival of the hemlock looper. And so that was a situation where a pest came through, almost wiped out the species, stayed in some refugia, and eventually it adapted to that pest, which is no longer an important pest of hemlock. It's still here, but it doesn't cause a lot of mortality. And then eventually, after the next glaciation event, it moved back through the landscape. But that doesn't help us in non-glacial time, right? In human time, it's not going to happen without some help. And that's why we're trying to bring in some of these species from the West Coast that are doing a good job to help control that here on the East Coast. The West Coast species did eventually evolve some sort of, we think that there's some resistance there as well, in addition to the management by biological controls. So it's possible that we can find resistant hemlock and help speed that resistance development along. Otherwise, it would take a very long time. We don't actually know what the mechanism would be yet. So it's almost like a can't hurt, might help strategy, right? Because there's no guarantee that we're going to find resistance, but there's also no compelling reason why there wouldn't be resistance. Does that make sense? Did that answer the question?
Yeah, I think that so. That was really interesting. Thanks for sharing. Let's see. I know someone was asking about any nurseries or potential sources of hemlock, and I saw some folks put in Plantsman Nursery. I don't know if anyone knows of any other nurseries that might have hemlock stock. I know there's also the Habitat Gardens of Central New York that shares their native plant list every year, shopping list or shopping guide. So I think, oh yeah, Frank, you just put that in the chat, right? Awesome. Thank you. That's a great resource.
Yeah, I think and it would be, if you look at the common names in that, it would say Canadian hemlock. I tried looking, I'm like, where's Eastern hemlock? But it came up as Canadian under common names. And on that list, so amongst, I think it was only noted the White Oak Nursery, but I would definitely, call your local tree nurseries. I don't know if Plantsman's even listed on that because it's Central New York. So I think both those sound like great leads to look into, and but call your local nursery, reduce your carbon footprint, first.
White Oak is great. They're in Rochester, and the gentleman who runs that also does HWA management work as well. And Plantsman is actually right here in Ithaca.
Perfect. Let's see. I'm not seeing any other questions that haven't been answered.
And maybe Camille, I don't know if on the follow-up, I did want to notice that, or just note that, Zeb, we've got some barriers of the treatment windows in the spring and fall are so reduced. Finding professionals like Zeb is really tough, and we're just really lucky. But it's difficult on the scheduling, and but maybe we could share as follow-up a way to look for treatment professionals through the DEC portal. They list who's certified to do this. If you're just looking to protect a few trees, you're not in a priority zone, and you want to, or just support the lake on your own, there are a variety of professionals. And the one thing I didn't know earlier is not only that chocolate milk for the clarity of the water. I didn't note that we're trying to reduce the excessive loading into the lake, because that is the food for these algal blooms that we take on. So anything we can do to mitigate that is the name of the game as well. So that's all part of it.
Yeah, absolutely. So yeah, any resources that you all want to share with me, I can send out in the follow-up email along with all of the recording and program evaluation and all of that. So yeah, I'll happily pass that along to everyone. Let's see. What did Tony say? Retired Cornell entomologist, impressed with the multi-tactic IPM approach to the project. That's great. Yeah, biocontrol, host plant resistance can be long-term solutions, but not always. So insecticides applied cautiously are useful. Yes, absolutely. Thanks, Tony.
And I'm dropping the link to the Elizabeth McCarty's overview in the chat. So it's there for anybody who wants to take a look at it.
Nice.
Amazing. Thanks so much, Carrie. Yeah, someone said they have a few trees or not around the lake, but have made numerous calls and haven't been able to find anyone who is certified to drive to their home. So yeah, I know that can be definitely a barrier to find someone. So we're definitely grateful for Zeb being here for sure.
Thank
yeah.
you. And yeah, if there, it would be good to have a list of multiple contractors, because everyone gets busy too. So a lot of times, you might not hear a call back from a contractor, just not that they're multiple contractors.
Great. If there are no more questions, we can wrap everything up. So I will just say a huge thank you to our speakers for today, Carrie and Frank and Zeb. And thank you so much for taking time out of your day to join us. Please don't forget to fill out our evaluation form and look out for an email from me coming in the next week with the evaluation, recording link, and any other resources. But yeah, thank you all so much for joining us today, and I hope you have a great rest of your day.
Thanks,
So
Camille.
much.
Thanks, Deb. Thanks,
Thanks,
Carrie.
everyone.
Bye.
Yeah.